Solar Probe is a mission where, for the first time, we're going to send a spacecraft into the upper atmosphere of the sun. We, for decades, have wondered what makes the sun so hot. We can see that the disk of the sun is 6,000 degrees in temperature, but we can also see that the corona, the atmosphere around the sun, is 1,000,000 degrees. How does that happen? How does it get so hot? We want to go in here and look at the electric and magnetic fields that happen as part of here in the acceleration region that give rise to the solar wind, that give rise to this hot corona that we see but we don't understand. We want to go to this acceleration region. We want to measure these electric and magnetic fields. And we're going to measure these things with this little gold box. It's sort of a souped-up car radio that measures these radio waves in space, and we build a little device like this to capture these signals to try to help us understand what gives rise to the solar wind and to the hot corona. And we'll put it on the spacecraft and launch it into space.
One of the things we're interested in is what we call space weather. We here in Minnesota know about space weather for a number of reasons. One is many of us have been lucky enough to see the northern lights. The northern lights are one of the beautiful aspects of space weather. They're driven by the energy in the solar wind interacting with our Earth's magnetic field, but they're also very devastating aspects of space weather. One is that the same phenomena that create the beautiful northern lights can make strong currents that can destroy power systems, or they can make very energetic particles that can destroy our communication satellites. And so we're very interested in being able to predict what's going to happen in the solar wind and these coronal mass ejections that Keith talked about and how they interact with our Earth's magnetic field. We've gotten undergrad students involved in looking at the data from some of Keith's early instruments, doing research papers on it, and I anticipate that we'll have lots of students who will have a chance to study these processes with the data from our Solar Probe instrument over the next 20 years.